If n is an integer, is n even? Okay, let's look. Statement 1 tells us that n divided by 2 is not an odd integer. Well, there's a lot of things that aren't odd integers, including both even integers and things that are just fractions. So, for example, if n equals 4, n divided by 2 equals 2, which is not an odd integer. If n equals 3, n over 2 equals 3/2, which is also not an odd integer. It's not even an integer at all. So the question is n even? If n equals 4, the answer is yes. If n equals 3, the answer is no. Sometimes yes, sometimes no. Big I for insufficient. It's not going to be A or C. Statement 2 tells us that n plus 4 is an even integer. Well, only an even integer plus an even integer can give us an even integers. And we know that 4 is definitely an even integer, and the statement tells us that this here is an even integer, therefore n itself must be an even integer. Let me restate that. Since 4 is an even integer on its own, it can only be an even integer that you can add to 4 to get an even integer. You could, for example, have what would be a good example? You could have two numbers that add together to be an even integer that are not themselves. So you could have 0.25 plus 3.75. Neither of these is an even integer, but they do add up to 4. However, if you know one of the two things is an even integer and you know that this is an even integer, this one must be. Therefore, n is even. This is sufficient to tell us yes, and it is choice B on its own.